Hello everyone, and welcome back to the Fluctus Channel. On the James River in Virginia, Newport News Shipbuilding is where America's nuclear-powered aircraft carriers are born, rebuilt, and returned to the sea. Founded in 1886, the shipyard has built more than 800 vessels and has been the Navy's sole builder of nuclear-powered carriers since USS Enterprise. Here, shipbuilders assemble hull sections, nuclear propulsion spaces, flight decks, and miles of internal systems. When one of these enormous carriers enters a dry dock, the same facility that created it can expose its underwater hull, complete major work, then float the ship again. The Gerald R. Ford class represents the next generation of American supercarriers. USS Gerald R. Ford, CVN 78, is the lead ship, named for the 38th president, who served in the Navy during World War II. Behind her came John F. Kennedy, CVN 79, followed by Enterprise, CVN 80. These ships operate as floating airfields. John F. Kennedy shows how a carrier changes from an enormous construction project into a ship. At Newport News, prefabricated sections are lifted into place and joined until the hull, island, hangar spaces, and flight deck become one structure. Enterprise follows the same sequence using digital work instructions. As Kennedy neared completion, attention shifted toward the systems that make a carrier operational. One of the most dramatic is the Electromagnetic Aircraft Launch System, or EMALS. Instead of a steam catapult, EMALS uses controlled electromagnetic force to accelerate aircraft. In February 2024, sailors, shipbuilders, and Naval Air Systems Command personnel conducted Kennedy's first dead load tests. Wheeled test vehicles weighing up to 80,000 pounds were accelerated down the track and launched from the bow into the James River, allowing engineers to verify the system without risking an aircraft. But before such systems can operate at sea, the carrier has to leave the dry dock. Floating a ship this large is a carefully controlled engineering operation. Workers inspect the hull, remove temporary staging, check underwater fittings, and confirm that openings below the future waterline are secure. The supporting blocks remain positioned until buoyancy takes over. Then, flooding begins slowly. During the 2019 flooding of the dock containing John F. Kennedy, more than 100 million gallons of water were admitted over several days. As the basin rises around the hull, engineers monitor draft, trim, tank levels, mooring lines, and the carrier's position. The goal is to keep the ship balanced, while the water gradually lifts a structure that had previously rested entirely on blocks. At first, the carrier barely seems to move. Then buoyant force steadily reduces the load on the supports until the hull floats free. This transition is critical. Once the ship is afloat, tugboats and line handlers control the next stage. If an unexpected list, trim change, or sideways movement appears, flooding can be paused while ballast and line tension are corrected. Every adjustment is deliberate because clearances inside the dock leave no room for uncontrolled motion from a carrier-sized hull. The gate can then open. Tugs pull and guide the carrier outward at low speed, transforming a basin that had functioned as a construction site into the first short channel the new ship will navigate. This launch is not a dramatic slide down a ramp. Instead, water is brought to the carrier until the structure becomes a vessel. The ship can then move to an outfitting pier, where electrical equipment, crew spaces, aviation systems, combat systems, and countless smaller details continue toward completion. Commissioning still requires extensive testing and training. The human side develops at the same time. Sailors assigned to PCU John F. Kennedy have described command values tied to the ship's namesake and to the responsibility of operating a nuclear-powered carrier. Before commissioning, they learn the vessel while shipbuilders are still completing it, gradually turning construction spaces into working compartments, watch stations, maintenance areas, and the daily environment of a future carrier crew. Training also reaches logistics. Carrier crews rehearse line handling and replenishment procedures because a deployed carrier cannot return to port whenever it needs food, stores, or spare parts. During underway replenishment, another ship can steam alongside while supplies cross between vessels by connected transfer rigs, with crews maintaining speed and separation. Practicing these routines prepares the ship to remain supplied during long operations far from shore. By the time a Ford-class carrier finally leaves the shipyard under its own power, its first contact with water may be long past. Yet dry dock flooding remains a decisive moment. It is when an immense assembly of steel, machinery, cabling, and aviation equipment stops behaving like a structure supported from below and begins behaving like a ship, ready for the next stages of testing before joining the fleet. Aircraft carriers are not the only Navy ships that depend on disciplined maintenance. Arleigh Burke-class destroyers spend much of their lives at sea, where salt, vibration, weather, and constant operations steadily attack exposed equipment. Sailors therefore perform routine preservation while underway, scraping corrosion, cleaning surfaces, checking fittings, and maintaining safety gear such as lifelines. Small jobs completed every day prevent larger failures from accumulating. When deeper work is required, the destroyer can enter dry dock. The principle is similar to a carrier, but the maintenance package may include hull inspections, propeller and shaft work, sea chest cleaning, valve replacement, painting, structural repairs, and servicing equipment that cannot be reached while the ship is afloat. Once water is pumped from the dock, the entire underwater body becomes accessible to technicians. USS Fitzgerald demonstrated why dry docking can also become essential after damage. In July 2017, the destroyer entered dry dock at Fleet Activities Yokosuka after its collision with the merchant vessel ACX Crystal. With the ship supported above the dock floor, inspectors could assess damaged areas that would have been difficult to reach in the water and prepare the vessel for extensive repairs. A more routine example came aboard USS Lassen in Yokosuka. Like every Navy ship, the destroyer periodically enters maintenance availability, so technicians can repair and renew systems before wear affects readiness. Crews isolate equipment, open machinery, replace damaged components, inspect piping, restore coatings, and test repaired systems before returning them to service. Dry dock also gives workers a rare view of components normally hidden below the waterline. Rudders, propellers, sonar-related areas, hull plating, and openings for seawater systems can all be examined directly. Water rises until the destroyer lifts from its blocks. Lines control the vessel as the dock fills, after which tugboats can guide it back into the harbor. The contrast in scale is enormous, but the logic remains the same as with a supercarrier. Place the ship on precisely arranged supports. Remove the sea from around it, repair what normally lies underwater, and then reverse the process. For destroyers expected to escort carriers and operate independently for months, this cycle is one of the quiet foundations of fleet readiness before the ship sails again safely. Submarines follow the same basic dry docking logic, but their shape and mission demand even tighter control. In 2015, the Los Angeles-class attack submarine USS Pasadena entered the floating dry dock Arco at Naval Base Point Loma. Tugboats and line handlers positioned the submarine over the dock's submerged support structure. Once centered, water was pumped out, allowing the dock to rise around the submarine until its hull settled onto carefully arranged blocks. For submarines, alignment is especially important because the long cylindrical hull must meet the supporting blocks at planned structural points, preventing concentrated loads from damaging the pressure hull while the dock continues to drain safely. With the boat supported and dry, technicians can reach areas normally hidden underwater. Because submarines depend on watertight integrity at depth, maintenance also includes rigorous inspections, testing, and verification before the vessel can return to sea. The process reverses during undocking. At Trident Refit Facility Bangor in 2021, USS Nevada, an Ohio-class ballistic missile submarine, was returned to the water after a major maintenance availability. Flooding gradually transferred the submarine's weight from the blocks back to the water. Once buoyancy was confirmed, lines and support craft guided the boat clear of the dock. After maintenance, submarines must prove that their systems work under operational conditions. USS Chicago conducted encapsulated harpoon certification training vehicle testing in 2020. The test was required before the submarine could carry and employ warshot tactical harpoon missiles. From inside the boat, crews prepare the encapsulated weapon, verify launch systems, establish firing parameters, and send it from a torpedo tube. After leaving the submarine, The capsule allows the missile to reach the surface before the harpoon transitions into flight. From supercarriers to destroyers and submarines, dry dock is where hidden parts of the fleet become accessible. Engineers drain away the ocean, repair what crews cannot reach afloat, inspect critical systems, and then carefully reverse the process by flooding the dock. The technique may look simple, but relaunching a giant warship depends on precise buoyancy, balance, line handling, and teamwork. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next time.